All right, so it's time to deploy this model. Like in this session, I'm going to show you how to deploy this model locally. That means that I'm going to be deploying it, running it on my own development environment. You can run it in your computer. You can run it in Project IDX. This is the same mechanism you would use. Let's say you wanted to deploy the model on a server running at your company to serve your company. Um, you can kind of open a port number and you can let people access that port number, and that's great. But I want to make sure this is clear. If you want to run this model at a production scale, where you're going to have multiple customers trying to connect to this model, then this might not be the best way of doing it. And that's why later on in the videos, I'm going to show you how to deploy this model in Azure and how to deploy it in AWS as two examples. You can also deploy it in Google and any server that you want. Those deployments are going to be more production ready. They're going to have the ability to scale. Like if you get multiple requests, you want to horizontally scale, basically run multiple instances of the model to serve all of that traffic. What I'm doing right now here is not going to do any of that. However, I don't want you to just discard that, because many use cases do not need any scalability above what a single instance of the model is going to offer you. Actually, many problems you can get away by doing what I'm just going to show you. Just very simple. So let's go here to my Project IDX interface and let's look at the README file. And in the README file, there's going to be a section that's called deploying the model. Okay, it's right after, I think, the training session. So here in deploying the model, I just created a command that is going to do that for you. Now, this command is a little bit more complicated than it needs to be because I'm combining multiple things. So this command will deploy the model, or will run a local inference server. Let's call it like that. It's more specific. It's going to run a local inference server with the latest version of the model registered in the model registry. That's a mouthful. So let's try to break that down. I'm going to go to the model registry here, and I'm going to look at default here, and you can see that the latest version is version 2. So I want to serve version 2 of my model on my computer. Okay, so I want to run a local inference server with version 2. So how do I do that? Well, this command here, it basically has two main components. The outer component is running the inference server. The inner component is connecting to MLflow and asking for the latest model version. That is this curl here. You see this curl? So I'm going to just get the curl and execute it and see what we get by running it. So I'm just going to get this, and let's open the terminal and let's execute that curl here. So I executed it, and as you can see, let me just make sure it comes across. Yes, it does. It returns version 2. I'm just going to remove some stuff so it's a little bit simpler. What do I do? I'm just trying to see where should I cut it. Okay, so I'm going to run this portion here. There you go. So I run that portion of the curl, and as you can see, it returns model versions as an array, and it's returning name, Penguins version 2, creation timestamp, blah, 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 blah. So this is basically returning from the MLflow API. I'm connecting to that API, and it's returning the latest model version because that's the version that I want to deploy. Something that I think I asked you to do in one of my assignments, this is going to be a good exercise. Take any of these commands that I put together by combining multiple pieces. Take them. I want you to copy them. Open Gemini. It's one of the secrets of using Project IDX is that you have access to Gemini. You don't have to pay for it. So Gemini is right here ready to help you. And just ask Gemini to explain those commands. And I don't know if it's going to work here because this is not a code file, but let me try. Explain the selected code in my editor. Let's see if it works. This is not an editor per se. So see, it's just explaining something else, which is not what I wanted because this is not an editor. So this is just a README file, the preview of the README file. That's okay. I'm just going to copy this. And I'm going to say, break down this command and explain every part of it. I mean, whatever. You can come up with a better prompt than that. But this is extremely powerful if you get, sort of like if you do not get what's happening, because there is a lot going on here. Gemini will do a pretty good job breaking down apart everything that's happening and explaining every single piece of it. That's one way that you can use AI here. So notice that in this command, I have the MLflow models serve command. I'm passing -m to indicate what is the model that I want to deploy. And that -m requires kind of like a URI to that model. And that's going to be models/penguins/ and then the version number, which I'm getting from this command right here. And this command, like we saw, this is the curl command, connects to the ModelFlow API, grabs the latest version of the model, and this JQ, which is a tool that I asked you to install at the beginning of the project, it comes installed here in Project IDX. You don't have to worry about that. But this JQ is basically a parser for JSON. So I can actually access that model versions 0, so the top one in that array, dot version. So that's going to return this dollar parenthesis here. It's just going to return that number 2. And then, obviously I'm going to be hosting this model in the local computer here, import 8080, and I don't want to use Conda, so it doesn't do any of that. So this entire explanation is going to be here. Let's see if it figures out that, oh, there we go, subshell command to get model version. So it does know that. The JSON, it explains. The JQ is a JSON processor. This extracts the version number of the first model version. So anyway, you get the drill. You can use Gemini to explain all of these commands. So let's run this command now. Let me close Gemini. I'm going to run this command, and we can just access, or we can just see the model run. So I'm going to click there, starting to initialize a bunch of stuff. You're going to notice here, sometimes this is normal. Sometimes this is going to happen. It says, I detected one or more mismatches between the model's dependencies and the current Python environment. And it says, MLflow, I currently have 2.17 installed here in Project IDX, but the dependencies of the model require 2.16.2. That is why here in the common file, as a reminder, if you open the common.py file, here I define the dependencies that I need, 2.16.2 in this case, but locally in Project IDX, I have 2.17 installed. Usually this is going to be fine, especially with those minor changes in version. Nothing should break our model. So we're fine, we're good. But I just want you to make aware that that's what's happening. If you wanted to fix that, you have two solutions. Number one is PIP install the correct version number in your local environment. Number two is going to the commons file, changing the version number to the latest one, and recreating that model, and then rerunning the model's serve. So you actually serve the new model with the new dependencies. There is actually a third way of doing it, which is there is a command in the MLflow documentation. I don't know if I have that here right now. Let's see. if I actually find that working, well, I'm not going to go through it. I'm not going to make you sit through me trying to find that. But there is a command that you can run that will update the PIP requirements of a model. If the model is in the model registry, you don't want to recreate that model, but the library is changed. Just want to change the requirements in the model. There is a command that you can run to update those libraries. So we're not going to worry about that. This is fine. So as you can see here, the final output here says loading model context. So we know the context of the model was loaded. The Keras backend is JAX. We set that up. And the data collection URI is going to be penguins.db, and the model is ready to receive requests. So this model looks pretty ready to me. So I'm going to open a new bash, and now I'm going to go to the README file. And I added here in the README file a curl request, just an example request that you can run to basically send samples to the model. And notice here is the format in JSON. Okay, this is how you send a JSON sample to the model that's already running. And by the way, if you go here to the ports, you're going to notice there is a port number now assigned to this model, which is 8080. It's running. We know it's running right here. Something that I really like to do is right-click in these bash names, like these terminals. So if you right-click, you can rename them. So I'm going to call it inference server, so I know exactly which one is which. I usually do that in my Visual Studio Code or Cursor, just so I recognize the different terminals. So let's see this curl command. So as you can see, it's a post command, and it has to go to the URL of my model. Because my model is running here locally, the URL is 0.0.0.0, okay? Port 8080, and I'm going to be calling /invocations. That is automatically created and provided to me. You know, I just realized that I've been watching this whole video looking at the wrong camera, which is funny to me, but that's fine. You're not going to be mad about that. So anyway, I was saying MLflow is, that's so funny. So just half the video, I don't know, we're like 12 minutes in, and I've been looking at the wrong camera for the whole time. This is the camera I should be looking at. Just things that happen. So anyway, MLflow, when we created our custom model, MLflow wrapped that custom model into a Docker container. That's what's happening here. I mean, it's just a container that's running. There is a /invocations route that's going to be created for us. And anything that we send to that route will be redirected to our predict function in the custom inference process. Remember, this is the file that we saw last session, and there is a predict function right here. It's going to be called that predict function with whatever we send to the /invocations. There are other routes as well, or endpoints. So we have /invocations. We have one that's called ping. We usually, cloud providers use the ping one just to make sure that the model is responding, that whenever I say ping, you have to return 200. There's another one that's called health. There's another one that's called version. So there are a bunch of them. So the one that we care about here to send a request is the invocations one. I'm passing a header, which is, hey, I'm just letting the model know that this is going to be JSON, and this is the data. And the data is just this JSON in this specific format. Now, there's many different ways that you can send data to a model, okay? You can also send data to this model in CSV format. I'm going to let you figure out how to do that. The MLflow documentation will help you out. In this particular case, what we care about is the inputs to the model is this array, and we have one sample here, which is this sample with all of the data about that penguin. So let's try this first, and then we can make it a little bit more complex. So I'm going to send this request, and when I execute it, I'm going to get back the predictions that for this particular sample. So I only have one sample. So we got a prediction of Gen 2. So this particular penguin is in Gen 2, and the model is 98% confident that that is the case. That sounds pretty good to me. We can give it another try by making this a tad more complex. So let me open here, not this. I'm going to open a new tab. How do I open? I forgot how to create a new tab here. I'm just creating because I'm inside the Visual Studio, the browser, and now I don't know how to create a new tab. How do I create a new tab? Not new window. I just want to create a new tab. All right, so let's do something different. I just don't know that is so dumb that I do not know how to create it. Would it be new text file? There we go, that's fine. All right, so I'm gonna add the command here, and I'm gonna grab this input. And if I wanted to send 2 inputs, I could do something like this, right? So now I'm adding a second input. I'm gonna change some stuff. I don't know. I'm just making stuff up. Probably, you know what? I'm gonna do something else. I'm gonna grab this. Why do we have AI? So I'm gonna open Gemini. I'm gonna say modify this command to send 3 samples instead of 1. Make up random values for the other 2 samples, taking the first as the template. Okay, I'm just trying to have a little bit of fun here. So hopefully Gemini is going to return a command that actually works. So let's see if that is true. Is it done? Not done? Still thinking. Okay, there we go. All right, so it returned. Okay, so it knows the penguin. It knows that. It knows Torgerson, and it knows all of that. Look at this. Visco, Dream. I'm surprised it knows about this data set. Torgerson. Okay, so awesome. So now I have 3 values. I'm going to paste my curl command, execute it, and this is what we get back. Okay, so this is great. We got back Gen 2 is the first prediction. We already saw that. The second one is going to be a Gen 2 as well with 77% confidence or 76% confidence. And the third one is going to be a Gen 2 with 97% confidence. Always returning Gen 2 just because the values are probably close enough for this to still be Gen 2. So anyway, here we just got 3 samples back. If we go to the inference server, you can see the logs. So let's see what's going on here. What am I looking at? Handling signal. So received prediction request with 1 sample, and then later on received prediction request with 3 samples. Okay, so all the logs are working. Now, as a reminder, we are not saving any data whatsoever. So if I list out a penguins.db, which is supposed to be the name of the MySQL database, there's nothing. And the reason there is nothing is because we're not capturing data. So let's fix that. And I probably have here a way to do that. So here is the same example in the documentation. Here you have the same example that I created before. But now I'm passing the list of parameters. So you can see params, and I'm passing data capture true. Okay? So if I execute this, so I'm still going to get a prediction back, but now I'm going to list out, how do I do that? List penguins.db. Now I have a SQLite database, which by the way, I have no idea how to open. Is there a command? Is there command line I can use to list the contents? Let's see if there is a command that I can use to list out the content. Just like that. Okay. Okay, let me just execute this and see if this is true. SQLite 3 is not installed. Yeah, I don't have it installed here. That is a good point. I'm gonna modify my development environment here to just make sure SQL 3 is installed. That would be a good idea. But just trust me, I don't have access to it right here. I mean, let me just see 1 second. It's not installed, but available in the following packages. Pick one to. You know what? Let me show you something because this might happen to you, and I want you to know exactly what to do if this happens. When this happens, I want you to open your dev.next, and inside the dev, don't save this. Inside the dev.next, you're gonna see a list of packages, and right here, you can just find the package that you want to install. In this case, this is gonna be SQLite 3.43. I bet this is the one. So I'm gonna add it. And the next time you rebuild the environment, SQLite is probably gonna be installed. Now, this is gonna take quite a bit of time as I click on rebuild environment because a lot of stuff is going on here. So I don't want to do it. But yeah, anyway, when that happens, you do that, you save your dev.next, and every time you open Project IDX, now you're gonna have access to SQLite, and you can see the content of the table. But just trust me, the content of the data is gonna be there just because we passed that parameter. Here is one thing about this local server running on your computer. By default, MLflow is using Flask to host this model. Now, there is nothing wrong with Flask. It's an extremely popular library, but there is a better way, a more production-grade server that you can use to host this model when you're deploying it to your company's network, whatever it is. And that is ML Server. Now, in order to run this or to host your model using ML Server, the only thing that you need to do, and you're going to have an explanation here, is just you need to pass enable ML server as a command, as a parameter to the same command you used to run, to host, to serve the model here. So I'm going to stop my server here. And now I'm going to go back. This is the same command that I used before. And I'm going to pass -- enable ML server. And when you do that, that will automatically, or not automatically, but that will run the same process that we saw before, but now it's running on ML server, which is gonna be way more professional, more production grade. It's gonna host your model in a much better way than Flask. Flask is great for development and whatnot. ML server is gonna be more production grade. Now I'm gonna go back here and I'm going to send, I'm gonna go back to the bash command so I can send a request and make sure this is actually working. Okay, so I'm gonna send, not this one here, which is the simpler one. I'm gonna send this request, and as you can see, we're getting back the same answer that we were getting before. Now, something that you need to know right now, as the time that I'm recording this video, the ML server does not support parameters. So remember that we have the ability to send data capture true or false per request. If you're hosting your server using ML server, you cannot do that right now. They have an open issue. They already have a solution for that open issue. I was opening that issue. I created comments there and whatnot. That has not been integrated in the latest version of ML server yet. So if you try to do that, it's going to fail. Just keep that in mind. It does not support parameters. So I'm going to try it right now just because I installed ML server fresh. I'm just going to go, I keep making that mistake. I'm going to go here and I'm going to find a curl command with a parameter. As you can see here, I'm trying to send a parameter. Oh, look at that. So it's already fixed. So apparently this went through. Yep, that was already fixed. Okay, so just scratch everything that I said. Apparently in the very, very latest version of ML server, they already they already support that. Let me just make extra sure that that's the case. Here's my server running. I'm going to go back. I'm going to do this again, saying parameters. Actually, you know what? I'm going to remove the database. This is the best test, isn't it? So I'm going to remove the database and resend the command. And here it is. The database was back created, and my server received that and store the input values here. All right, so scratch what I said. The latest version of ML Server is running fine. It's good to go. So yeah, this is great. This is awesome. So that is everything that you need to do in order to get this working on a server. In the next video, I'm going to show you how to start generating traffic at scale, because that's going to be very important if we want to simulate or monitor our model. So I'll see you in the next one.